And now we're ready to actually take our conductivity measurements. And so the first thing that we have to do, very similar to when we took our turbidity measurements earlier, first thing we have to do is calibrate our conductivity probe. So you can see the conductivity probe looks like this. And I literally will just be sticking this probe right down into the solutions. One thing that I have to make sure of, actually, let me just bring this in a little closer so you can get a good view of the probe here. So this is what the probe looks like. As I'm taking my measurements, I have to be sure that I am actually sticking the probe in deep enough so that that little glass bulb is fully immersed. And so that window gives me a good guide. I just have to make sure that the clear window in here is fully immersed in my solutions. And so, like I said, the first thing that we have to do is to calibrate the probe. And so what I'm going to do is, again, just follow the directions for calibration, although I've done this enough so that I know what I'm doing. But if you were here doing it, you would simply follow our directions for calibrating the probe. We're using 2 points to calibrate. One of those is with distilled water, which just has a conductivity of 0. And so I stick the probe down in there, again, making sure that I am fully immersed, and there's not quite enough water in there to fully immerse it, so you'll see what I'm doing is just tilting the beaker a little bit, just to get it deeper on one end to make sure that it is immersed in there. So there's my 0 point. I just shake the probe off a little bit into my waste beaker. And then we have a 1000 microsiemens per centimeter standard. And so I can just stick the probe right down into that standard. And just as you saw what the screen looked like with the turbidity video, what I'm looking at here is just that Logger Pro screen, which is measuring my conductivity down in the lower left. And to just double check that it is measuring the standard correctly, or that it's measuring correctly in general, I'm just going to take it out, stick it back into the standard, and I see that it is measuring the standard at 1003 microcentimeters per centimeter. So that tells us that we're pretty well calibrated. Just to double check that even further though, I'm just going to rinse off, just use my squirt bottle, rinse off the probe, shake off any excess, then I'm just going to put it down into the distilled water to make sure that it is measuring that at 0. And it's measuring it at 4, actually, microsiemens per centimeter. Pretty much 0 when we're looking at our calibration range of 0 to 1000. And so now I'm ready to measure the conductivity of all my various samples that we prepared earlier. And so the first one that I'm going to start with is the 0.025 molar NH4NO3. We always like to get measurements in triplicate whenever we can. And so what I'm going to do is stick my probe down in, let it stabilize, get my measurement, take it out, rinse it off, and put it back in. And I'll do that for a total of 3 measurements so we can get our triplicate measurements. And again, all this data will be provided for you, but I will shout out the numbers as I am getting them as well. Conductivity does tend to jump around a little bit, so I watch until it's fairly stable. For 4,215. Again, these are all microsiemens per centimeter. Now, some of you are hopefully asking, well, this is outside the calibration range. With turbidity, we had to actually redo this, or we had to dilute a sample down so that it was within the calibration range, which was true. For the turbidity probe, we didn't necessarily know if the instrument was accurate outside of our calibration zone. For this one, we do. We just know that about this instrument, that it is accurate outside, and so we are comfortable taking measurements that are above our actual calibration window. Measurement 2, 4,210. And measurement 3, 4,180. You'll note again, just sort of as a lab organizational tip, that now that I know I am done with that solution, or I should be done with it, so I set it off to the side. I didn't dump it out yet, just in case something does go wrong throughout the experiment and I need it again for some reason. But I set it off to the side just to get it out of my way so I didn't accidentally grab for it later. So now the 0.020 NH4NO3. First reading, 3,430. Second reading, 3,440. For our third reading, 3,390. And now the 0.015 molar NH4NO3. First reading, 2,610. Second reading, 2,620. And my third reading, 2,590. Now you may note, just as a side note, that all the measurements I'm reading, I'm only reading off to the tens spot. I guess except for my very first one. Conductivity probes are fairly sensitive, and so this is something, unfortunately, that you can't really see. And I have my camera set up well right now, so I don't want to move it. But conductivity measurements jump around quite a bit. And so what I'm doing is I'm sort of watching it, like on that last one, I was watching it fluctuate quite a bit between 2587 or so and 25, and about 2600 actually. So it sort of kept bouncing around in that range. Once I saw that it was bouncing around just in that range and not going beyond it, then I just sort of did an internal estimate and said, well, it's basically bouncing all around 2590. And so I made the judgment that that's what the measurement was. And so that's why these are all only going to the tens spot. And lastly, our 0.010 NH4NO3. Our first reading, 1,810. Our second reading, 1,780. And lastly, our third reading, 1,800. move on to our other solutions. The CaCl2, 0.025 molar CaCl2. First reading, 4,280. Second reading, 4,260. And my third reading, 4,290. Now our 0.025 molar sodium carbonate Na2CO3 solution. Our first reading, 5,150. Our second reading, 5,210. And our third reading, 5,320. And last but certainly not least, our 0.025 molar glucose, the C6H12O6. First reading, 48. Second reading, 36. And my third reading, 34. Okay. The next part of conductivity, the conductivity part of the slab, this module, has me mixing together my Na2CO3 and my CaCl2 solutions. So I'm going to go ahead and just mix the two of those together completely. So I'm just using another beaker for that. So here's my CaCl2. Then actually I'll come in closer to the camera and dump in the Na2CO3. So here's my CaCl2 in here, and now my Na2CO3. And you can see how cloudy that got immediately. And it's tougher for you to see, but I don't know if you might be able to. I'm starting to see some precipitate form. I'm starting to see some solids forming in there. And so what I'm going to do now, so eventually I want to measure the conductivity of this mixture, but I want to allow for those precipitates. I want to allow for those solids to actually settle out before I get that measurement. So I'm just going to set this off to the side and measure the conductivity of the Green River sample spots first, and then I'll come back and measure the conductivity of this mixture. So here we have the 5 Green River sample spots. I'm just getting my notebook ready for all of these. Now let's go ahead and measure the conductivities. So Green River sample spot 1. First conductivity reading, 120. Again, these are all still microsiemens per centimeter. We haven't changed anything as far as our units go. Conductivity reading number 2, 125. And conductivity measurement number 3, 121. Again, you'll note lab practice. I always try to make sure to cap my solutions immediately when I'm done with them. Sample spot number 2. I'll get these all ready to go in order so they can be quicker and more efficient. So Green River sample spot 2, first conductivity measurement, 505. Second measurement, 507. Third measurement, 512. Green River sample spot number 3. First conductivity measurement, 610. Second measurement, 595. And our third for sample spot 3, 586. Green River sample spot 4, 970 for the first reading. $982 for the second reading. $954 for the third reading. And last but not least, Green River sample spot number 5. Sorry, it didn't look like my video was recording. It is. reading number 1 for sample spot 5, 1050. Reading number 2, 1040. And finally, reading number 3, 1035. So those are all the readings for our Green River sample spots. Let's take a look at our mixture. Starting to settle out, but what I think I'm going to do is allow this even more time to settle. I'm going to stop this video in just a moment, and then I'll go on and start up the pH video. At the very end of the pH video, I'll leave the conductivity probe all plugged in, ready to go. At the end of the pH video, that should be settled enough, and I'll take the final conductivity of that mixture, just to give it some more time to settle. And so this concludes, until I do that part, this concludes the conductivity portion of Module 2. Stay tuned for pH.